Hello everyone, welcome back to the channel and to the next session of dynamic programming where we are going to look at the Knapsack 01 problem and try to solve it using dynamic programming. So first, let's understand the problem. Let's say we have a knapsack or a bag with the capacity of W. And then we have some items, let's say item 1, item 2, item 3, and item 4. Every item has a value and a weight. So V1 is value 1 and W1 weight 1 for item 1. Similarly for all the items. Now we want to try to put all these items in the knapsack and get the maximum value. So if I put some values, let's say the knapsack capacity is 6 and the item 1 value is 3 and its weight is 4, then 2 and 3, then 4 and 2 and 4 and 3. So if I try to put all the items in the knapsack, the total weight is going to be 4 plus 3 plus 2 plus 3, which is not possible. The total weight will come out to be 12, but our total capacity is, let's say, 6 kg. So we try different combinations and try to put whatever item gives us a maximum value. So let's say we try to put item 1 and item 2. This is going to give us a weight of 2 plus 4, which is 6, which is under the maximum capacity. So the maximum is 6 kg and we are getting 6 kg. So we can put item 1 and item 2 in the knapsack and those are going to give us a value of 7. Okay, let's try a different combination. So let's say we try item 1 plus item 4. The weight will be 4 plus 3 is equal to 7 kg. We cannot put item 1 and item 4. Okay, let's say item 3 and item 4 will give us a weight of 2 plus 3 is equal to 5 kg. So we can put item 3 and item 4 in the knapsack and this is going to give us a weight a value of 4 plus 4 is equal to 8. Okay, so we can try different combinations. We can try item 1 plus item 2 plus item 4 and so on. And these will be a lot of combinations. So using a brute force technique, it will be tough to find all the solutions. And in this case, dynamic programming helps us solving Knapsack 01 in a much more efficient way. So in this session, we are going to solve the problem using some common sense, and then from that solution we will try to find the recurrence for the problem and then solve it using the recurrence in a more technical way. This will give you a hands-on on both ways to solve the problem, and probably that will help you with your academics or if you are preparing for some interviews. So now let's see a problem. We take the same problem. Let's say the capacity of knapsack is 6. We have 4 items, 1, 2, 3, and 4. V1, V2, V3, and V4, W1, W2, W3, and W4. So the values are 3, 2, 4, 4, and the weights are 4, 3, 2, 3. Now here we have two variables. One is items and the other is weight. If you remember the previous session where we solved the weighted sum on a line graph, we had only one variable, which was the nodes on the graph. So what we did was we took a 1D array, put a 0 on the dummy index, and then we calculated the weights. Similarly, we are going to do the same here and create a 2D array, because now we have two variables. So the array is going to be, the x-axis is going to be the items, and this will be n plus 1, and the y-axis is going to be the weights, 1 plus w plus 1 grids. So let's try to create a grid. Okay, we need 5 columns for I, which is items, and this will be, let's say, x, which will be weights. So this is, and let's see, 1, 2, 3, 4, 5 and 6. 0, 1, 2, 3, 4, 5, 6. So this is capacity 0 here, this is capacity 1, this is capacity 2, this is capacity 3, 4, 5 and 6. Okay, now let's see. We will have a, let's say, I go from, now similarly like the previous line graph problem where we had put a 0 on the first index, here we are going to put 0 on the first column because there is no item 0. So this is our dummy index or dummy column. Now for every I from 1 to n, we are going to calculate weights from 0 to w. Okay, so this is 1 to 4 and this is 0 to 6. Okay, so when I is 1, this means we can pick item 1 and try to put it into the knapsack. So when I is equal to 1 and my capacity is 0, I cannot add this item. So I get a value of 0. When I have I equal to 1 and my capacity is 1, I still cannot add this item because my knapsack capacity is 1 and my item weight is 4. So I get a value of 0, 0, 0. Now here things are going to change because my item 1 weight is 4 and I reached to a capacity of 4. I can add this item, and when I add this item, I'm going to get a value of 3. Similarly, for when my capacity is 5, I will keep the value 3 and I will keep the value 3. Now when I is equal to 2, this means I can pick either of these items. I can pick item 1 or item 2 or both the items if I have enough capacity. So at 0, nothing can be picked. At 1, nothing can be picked. At 2, nothing can be picked. At capacity 3, we can pick item 2. So when I pick item 2, I am going to get a value of 2 here. Now at capacity 4, I can pick item 1 because its weight is 4, and I can also pick item 2, its weight is 3. So then I am going to look at which item is going to give me a better value. So item 1 is going to give me a better value. So instead of picking item 2, which we picked when the capacity was 3, I'm going to pick item 1 and my value will be 4, right? At item, when my capacity is 5, I will still pick item 1 and get a value of 4. When my capacity is 6, I will still pick item 1 and get a value of, because at capacity 6 I cannot pick both the items, because then the weight is going to be 7, which is more than the capacity of 6. Okay. Now when I have I is equal to 3, this means I can pick either or all of these items 1, 2 and 3. So at capacity 0 nothing can be picked. At capacity 1 nothing can be picked. At capacity 2 I can pick item 3 because its weight is 2. So then I am going to get a value of 4, right? At capacity 3 there is a possibility that I can pick item 2 as well as item 3, because item 2 has weight of 3 and item 3 has weight of 2. So capacity 3 I can pick any of these 2 or 3, but I'm going to look at which item gives me more value, and item 3 is going to give me more value, so I'm going to pick item 3, right? At capacity 4 I can pick all these 3 items, because all these 3 items have weight under or equal to my current capacity. So I'm going to look at the value, and the maximum value is 4. So I'm going to pick item 3 here. Okay. So now let's see here. Here things are a little bit interesting. So let's look at when my I is equal to 3 and capacity is equal to 5. Okay. This means I have a bag which has a capacity of 5, and I can pick item 1 or I cannot pick, I'm sorry, either I can pick item I or I cannot pick item I. So if I don't pick item I, which means this item, that means I am going to pick item 1 and 2, the maximum of when I was able to pick item 1 and 2 and when the capacity was 5, which is 4. Okay. So if I don't pick item I, which is item 3, then I am going to get a maximum value of 4. Okay. Now again, let's look at, if my again knapsack is 5 and I want to pick item I, which is 3, I is equal to 3. This means I need a weight of 2. So I need a weight of 2 here, so that I can add item 2 in this knapsack and get a value of 4, right? Then how much is left? 3, which is going to come from the previous sub solutions. So what was the maximum value when I was 2 and capacity was 3, which is I was 2 and capacity was 3 is 2. So when I was 2 and capacity was 3, then the maximum value was 2, and we also are able to pick the current item. So this means I will have total 3 plus 2, 5, right? So I can accommodate, because so then and I am going to get a value of 6. 2 plus 4, 6, right? So what we did for this is, either we pick the previous item, which we did here, and this carried forward, or we take the current item, so whose value is 2, oh I'm sorry, whose value is 4, and we pick the current item, plus the value at 5 minus 2. 5 minus 2 is weight 3, right? So then 2 plus weight of third item, so which is 4 plus 2 is equal to 6, right? Now for this one, when the capacity is 6, we can pick item 1 and item 3, because this is going to give us a weight of 4 and 2. So 4 plus 2 is 6, which is under our current capacity, and we are going to get a 7. This came like the same way. Either we don't pick the current item, so then we are going to pick the previous item, or what was the maximum value when the capacity was 6 and I was 2. We are currently at 3. Okay, so that was 4. This means when I was 2 and the capacity was 6, then the maximum profit was 4. Or we want to pick the current item. So this is I is not picked, or I is picked. If I is picked, then we need to make a room for weight 2. This is 2. Okay, so this is total 6, and this is going to give us this is 2, and this is going to give a value of 4, and this is total 6. So if I want to put item 3 in this, which has a weight of 2, then what is left is capacity 4. So what was the value at capacity 4 in the previous item when I was 2? So I was 2 and capacity was 4. It was 4. I think I made a mistake in the previous column. When I was 2, this cannot be 4, because when I is 2, that means we can pick any of these, and when the capacity is 4, this means we can pick item 1 or item 2. So the value of item 1 is more, so this should have been 3 actually. Similarly, this will be 3, this will be 3. Okay, so then our calculation for this will change, and this is going to change. Okay, so let's look at this again. When my item is 3 and capacity is 5 item, then we can take any of these, right? So my capacity is 5. What I'm going to do is I'm going to pick item 2 and 3, which will give me a weight of 5 and a value of 6. So 5 can fit into the knapsack, and I get a value of 6. How did this came up? So when my capacity is 5, either I can pick this item, ith item, or I don't pick this item. So if I don't pick this item, then I am going to don't pick item 3, then my maximum value is coming from item 1 and 2 when the capacity was 5, right, which is 3. So this has to be 3. When my item was 2 and the capacity, this calculation here. Okay, so I am not picking the current item, and this means my value is coming from item 1 and 2. Or if I want to pick the current item, then I need to make space for its weight, which is I is equal to 3 and weight is 2. So weight 2, it is going to give me a value of 4. Now if I want to make space, then the total capacity is 5. 5 minus 2 is 3. So this 3 is going to come from the previous sub problem, which is problems 1 and 2. So at capacity 3 and when I was 2, the value was 2. So for a capacity of 3 when I was 2, the value is 2 and this. So this turns out to be 6. Similarly, when item is 3 and capacity is 6, either I pick this item or I don't pick this item. If I don't pick item 3, then the value is coming from item 1 and 2 when the capacity was 6, which is 3. Okay, or if I pick the current item, then I need to make space for this. Its weight is 2, so I reserve 2 and it is going to give me a value of 4. Then the capacity which is left is 4 out of 6, and this 4 is going to come from item 1 and 2. So item 1 and 2 at capacity 4 was 3. So 3. 4 plus 3 is 7. And if we look at in a general way, when I have 3 items and I want to pick 3 items, any of the 3 items, I think we can pick item 1 and item 3, which will give me a weight of 4 and 2, 6, and my current capacity is 6. So these 2 items can fit into the knapsack and they are going to give me a value of 3 plus 4, 7. So that's how we are going to do the calculation, and I think this part is important for you to understand because this part is going to help in creation of the recurrence. Okay. Okay. Now when item 4 is picked, this means we can pick any of these items. So when the capacity is 0, nothing can be picked. When the capacity is 1, nothing can be picked. When the capacity is 2, only item 3 can be picked and it is going to give a value of 4. When capacity is 3, these 3 items can be picked and item 2 and item 3 are going to give us the maximum value. So let's say we keep item 3 from here, and when capacity is 4, then item 1 can be picked, item 2 can be picked, or item 3 can be picked, or item 4 can be picked. So let's say we carry forward the previous. When capacity is 5, then we can pick item 2 and 3 because this will give a value weight of 5, or we can pick item 3 and 4, which will also give a weight of 5. Then the maximum value is actually from item 3 and 4, which is 8. Okay. Then when the capacity is 6, we can pick 2 and 4. I'm sorry, item 2 and 3, 3 and 4, or 2 and 4. Right. So then this is going, item 3 and item 4 is going to give us the maximum value, which is 8. And this is our answer. So this was done without the recurrence. Now, if we try to create a recurrence based on our logic here, then we can say we have I is equal to 1 to n, and then x is equal to 0 to w. Okay. Before that, we are going to initialize our 2D grid. So we say a 0 comma x is equal to 0 for all x. This means our 0th item for every weight, which is our first column, we make it 0. Okay. And then we have a loop and now we have to pick a value for the index, which is current item and current weight, which is going to be maximum of either I don't pick the current item, so then I'm going to pick the previous item with the current weight. This is, I am not picking the current item, or I pick the current item. So then if I pick the current item, I am going to get its value and I will make room by subtracting its weight. This is when I am picking the current item. That's the recurrence. Okay. So if we again visualize it, let's say my I is equal to 3, my capacity is equal to 5. Here I is 3 and capacity is this, so we get a 6. Now what does this mean? If I don't pick item I, which is item 3rd, or I pick item I. If I don't pick item I, which is 3, then the solution is going to come from 1 and 2, right, for a capacity of 5. So solution from 1 and 2 at capacity 5 was 3. Okay, so I get a 3. This is this one. And if I going to pick the current item, then what I need to do is I need to make room, because I need to make room for the ith item, which is 3, and ith item is weight is 2, so this is 2, and it is going to give me a value of item 3, which is 4. And when I make room for this ith item, then rest of the part is going to come from the previous items, which are 1 and 2. So when I was able to pick 1 and 2, what was the maximum value when the capacity was 3. So at 2 and capacity 3, it was 2. So then when the capacity was 3 and item 1 and 2 were picked, the value was 2. So this is 6. This is 3. So which one is maximum? 6 is maximum. So we are able to pick this condition. That's how you are going to build this grid using the recurrence. So let's try. I need one more row. Okay. Zero, 1, 2, 3, 4, 5, 6. Okay. Now this one 0, 0, 0, 0, 0, 0, 0. Okay. I'm not going to do the whole recurrence. Let's say I fill the first two columns without following the recurrence. So I get 0, 0, 0, 0, 3, 3, 3. And for the second column, I get 3, 3, 3, 2, 0, 0, 0. Okay. Now, zero, zero, zero. Okay. Now let's say when I is equal to 2 and x is equal to 3, we get the first condition a I minus 1, which is 1 and 3, which is 1 and 3 is 0. And this is when I don't pick the current item. So the value is coming from this one. Okay. And if I'm going to pick the current item, then it is I minus 1, which is 2 minus 1, 1, and x is 3. 3 minus w2 is w2 is 3. Oh, I am sorry. This is I is equal to 3 because we are at this one. So then a 3 minus 1 is actually 2 and 3, which is second and third weight, which is actually this. So this is 2. And the second condition is a 2 and 3 minus w2, w3. W3 is 2. So then this will be x is 3 minus 2 is plus value of 3, which will be 4. So we get a 4 here. Let's say I want to calculate for I is equal to 3, x is equal to 5, weight 3 is equal to 2, okay, which is actually this grid. So this will be A 2 5, which is 3, this value, and the next is a I minus 1, which is 2, and x minus wi. 5 minus 2 is 3, plus value of 3 is 4. So 2 and 3 is 2. So then 2 plus 4 is equal to 6. So we get this. Next, let's say I is equal to 3, x is equal to 6, w3 is equal to 2. Then we get a2 6 is 3, and a I minus 1 is 2, and x minus wi is 6 minus 2 is 4, plus value of 3, which is 4, and then this will be this and this, which is 3 plus 4 is equal to 7. So that's how you are going to solve the grid using the recurrence. Let's say we want to find the final grid item. So which is I is equal to 4, x is equal to 6, and w4 is equal to 3, and v4 is equal to 4. So the first condition is I minus 1 is 3 and x is 6, which is 3 and 6 7, and then the another condition is I minus 1 is 3 and x minus w, x is 6, w4 is 3, which is 3, plus v4 is 4. So 3 and 3 is 4, plus 4 is equal to 8. So this is bigger, we get 8 here. That's how you are going to fill the grid using the recurrence. Or if you want to do without recurrence, I already showed you above how to do that. Now we already know the answer, which is 8, but we don't know what all items were part of the solution, and this is called reconstructing the solution, as we discussed in our previous session on the introduction of dynamic programming, where I discussed the line graph with you. So either 8 came from previous subproblem if I was not part of solution, and if I was part of solution, then 8 came from its weight, its value, I'm sorry, and the maximum value when I was 3 and x was current weight, capacity minus current weight. So capacity is 6 and current weight is 3. So then it came from 6 minus 3 is 3. So 4 plus its value 4. 4 plus 4 is 8. So definitely it came from the second condition, and this means we can pick this item. So our solution is going to have item 4. Now we are at this item because this 8 came from this 4, and this 4 is I is equal to 3 and x is equal to 3, right? So either this 4 came from this 2 if I was not part of solution, and if I was part of solution, then this 4 is weight of value of 3. So the value of 3 was 4, and if we reduce the weight, so W3 is 4. So then 3 minus 2 is this. So this is 0 plus 4 is equal to 4. Definitely the solution came from this and not this. So we add item 3 to the solution. After that we don't see any values, so no item was added, and our solution is item 4 and item 3. So it's pretty simple. Either you take this or you go in the previous column and reduce the current weight. So current weight is 3, so 6 minus 3 is 3, and take this item and reach here. Okay, now similarly, if this value is same as the previous column, then pick this item or go to the previous column and reduce the weight of third item, which is 2, and 3 minus 2 is 1. Go here. This way you are going to reconstruct the solution. I hope this session on Knapsack 01 problem solution using dynamic programming was helpful for you. If you have any questions or doubts or any section you were not able to understand, post in the comments and I will try to answer. Bye for now, and I will see you in our next session on dynamic programming. Thanks for watching.